Hello and welcome to Unit 2.1. Here we're going to take a look at some of the main types of water reuse projects and talk about some of the benefits and risks of each. We'll also touch on opportunities for the recovery of nutrients, energy and metals from the wastewater treatment process. At the end of this module, learners will be able to understand and explain the main types of water reuse in different sectors, identify different resource recovery opportunities from wastewater, and describe the benefits and risks related to water reuse. By retaining part of the used water from our cities or industries, water reuse secures a part of the water available within the water cycle. It can be integrated into our current water cycle by creating inner loops to substitute abstraction of freshwater from freshwater sources when reclaimed water is used directly for irrigation, industry, or even domestic purposes. Additionally, wastewater treatment byproducts like biosolids and other recovered resources like nutrients, energy, and metals can be extracted and used again for higher value purposes. Wastewater reuse in agriculture is a key strategy to address water scarcity and enhance resource efficiency. Treated municipal wastewater provides a reliable year-round water supply that can substitute for freshwater withdrawals, particularly in arid and semi-arid regions. Boostin is exploring this reuse type in Italy and Spain. Beyond water provision, reclaimed wastewater contains valuable nutrients such as nitrogen and phosphorus, reducing the need for synthetic fertilizers and lowering production costs. However, the practice requires careful management to minimize risks. Treatment processes must meet quality standards appropriate for crop type and irrigation method to prevent soil degradation, salinity buildup, and potential contamination by pathogens or trace chemicals. International guidelines, including those of the World Health Organization and the Food and Agriculture Organization, emphasize risk-based approaches, monitoring, and safe irrigation practices. When properly managed, wastewater reuse supports agricultural productivity, promotes circular resource use, and contributes to sustainable water management. Industries are also large consumers of water. They can be users and/or producers of reclaimed water. Internal recycling is already commonly implemented in industry. The use of reclaimed water from municipal treatment plants is just a step further. Water reuse for cooling purposes is the most common use because it generally consumes the most water. Moreover, cooling practices are often similar from one industry to another, so examples and guidance are easier to find, making it easier to implement such projects. Reclaimed water is also often used to supplement boilers, although a very high level of treatment is generally required, particularly regarding chloride removal to avoid deposits and damage to equipment. Reclaimed water can also be used within specific industrial processes. However, because these processes are usually industry or even site-specific, the use of a different water quality can impact the process and the final product, making them more difficult to implement and therefore less common. The Boostin team are currently looking at industrial reuse opportunities in Greece. Most of the wastewater comes from the city, so it makes sense to use it within the city, thus reducing drinking water consumption. Urban uses such as watering of parks and green spaces, street cleaning and sewer cleaning become logical uses for reclaimed water. However, given the urban context and the risk to the general public, the quality of the recycled water generally needs to be higher than that required for irrigation. Practices are also often adapted to reduce the risk of the public coming into contact with the reclaimed water, such as watering green spaces at night to reduce the risk of exposure or requiring workers exposed to reclaimed water to wear protective equipment. It is technically possible to treat wastewater to make it drinkable. Some countries have already implemented indirect potabilization of reclaimed water, and a few even use direct potabilization. Indirect potabilization consists of infiltrating or injecting reclaimed water into freshwater reservoirs such as reservoirs, aquifers, or rivers upstream of drinking water production plants. For direct potabilization, drinking water is made directly from reclaimed water without passing through a natural water reservoir. In 2024, there were 48 potable reuse projects operating around the world, including 6 in Europe. Many others are under various stages of exploration, planning, or construction. Obviously, the levels of risk are high, and therefore the risk management and planning requirements for such projects are similarly high. The Mediterranean coast of France has been targeted for exploring potable reuse opportunities as part of the Boost In project. Nutrient recovery from wastewater is an emerging strategy that transforms treatment plants into resource recovery facilities. Municipal and industrial wastewaters contain significant quantities of phosphorus, nitrogen, and potassium, which are critical elements for agriculture and also sources of receiving water pollution. Traditional treatment often removes these nutrients to protect receiving waters, but recovery technologies allow their capture and reuse, reducing reliance on finite resources. Boost-In is exploring opportunities for nutrient recovery in Germany. Phosphorus can be precipitated as struvite, a slow-release fertilizer with high agronomic value. Nitrogen can be recovered through processes such as air stripping, ion exchange, or membrane technologies, producing ammonium salts for fertilizer use. Potassium, though less concentrated, can be extracted from sludge ash or recovered alongside other nutrients. One major energy recovery pathway is anaerobic digestion of sludge, which generates biogas rich in methane, which can be combusted on site to produce electricity and heat, offsetting plant energy demand and reducing greenhouse gas emissions. In addition, wastewater itself contains low-grade heat that can be recovered and directly reused for district heating, industrial applications, or to improve plant efficiency. And finally, after dewatering and drying, biosolids can be combusted to generate electricity or heat, with the added benefit of reducing sludge volumes. Locations with certain industries are also often the targets for metal recovery, such as the leather and tanning industry, electroplating and smelting, printing and dyeing, as well as the mining industry. These activities often see wastewater discharges with higher than normal concentrations of different metals that can be recovered. Removing metals can improve the environmental health of receiving waters and water reuse opportunities, particularly in agriculture, where high metal levels may affect soil and plant health. Extraction methods may require significant investment, and the viability may depend on the metal concentration of the water and the market value of the metal. Boost-In is working with partners in Bulgaria to explore opportunities for metals recovery in the mining sector. And finally, here are 3 important takeaways from this unit. Developing water reuse projects requires a risk assessment and management approach. We will never have perfect information about health or environmental risks. We need to use the best information we have available to estimate the likely level of risk and design treatment and management actions to reduce risks to acceptable levels for stakeholders. Reducing risks is important, however, it's generally impossible, extremely costly, and practically unworkable to try to eliminate risks completely. This is where the idea of treating wastewater to a quality level that is fit for purpose comes in. Water used for irrigating fruit trees, where the water never touches the fruit, doesn't need to be the same quality as water for irrigating vegetables eaten raw that come into contact with irrigation water. And lastly, circular economy in the water sector doesn't just mean water reuse. Keep an eye out for opportunities for nutrient, energy, and metals recovery projects as well. Thanks for your attention, and don't hesitate if you have any questions.